All right, hey everybody, we are still doing predicate derivations, and this is the video discussing our third new rule called existential out. And this one's a little more complicated than either of the two we've seen so far, but I think we'll be able to figure it out here. So existential out, I'm going to describe it here, and then we'll have another set of videos doing some example problems just as before. Hope everybody's doing well. All right, if I can make this, oh, that's not right. If I can make this screen go forward, that'd be good. Here we go. All right, so here's the idea behind existential out. Let's let mx, just for the sake of this example, mean that x is a mother, right? Now consider this question. If I know that that formula is true, existential x mx, do I know that mx is true for any constant that replaces x? That is, could I conclude ma and mb and mc and so on? And if you think about it, the answer is no. That is, just because I know that that formula, there is an x, mx is true, that is, something is a mother, I don't know that any particular thing I name is a mother. If I know that something is a mother, I can't conclude that A and B and C and D and all of those people are mothers. That's just not a valid way to reason. However, that's what this says. Just because something's a mother, it doesn't follow that any named thing is a mother, right? So no, you can't reason that way. But we do sometimes do something like this when we argue. And so let me give an example of how we might sometimes do this. So you might argue in the following way, and this is sort of a simple example, but maybe you'll recognize the style of argument. You might say, look, I know there's at least one mother in Greencastle. So for the sake of argument, let's call her Judy. So I say, okay, from the fact that there's some mother, I conclude that Judy is a mother. Right? That's the little move we just made there. And then I might reason like this. So for the sake of argument, call the mother Judy. Well, if Judy's a mother, then Judy's female. So there must be at least one female in Greencastle. That's a perfectly good way to argue. And notice that what I did is I sort of did something like took off the existential quantifier. I said, there's at least one mother, therefore Judy's a mother. So I did something sort of like what we talked about on the previous slide, but everything seemed to work out okay. Notice, however, that if you do reason like this, like the reasoning in the green box right there, you can't already have somebody named Judy in mind and then infer something about that person. That is, if you have a friend named Judy, you can't have her in mind and then infer that your friend Judy is a mother from this style of reasoning. That is, this kind of reasoning in the second green box would be clearly inappropriate. So it says, I know there's at least one mother in Greencastle, so let's call her Judy. But my friend is called Judy, so my friend is a mother. That's not okay, right? You can't reason that way. The only way this kind of reasoning works is when Judy is in some sense arbitrary. It's sort of like a placeholder name. It's not really referring to any person you know called Judy. You're just sort of using the name as sort of a placeholder to do some reasoning. That's exactly what we're going to try to capture with our existential out rule. We're going to try to come up with a rule that lets us take off an existential quantifier and replace the variable with a name, but it's going to be like a dummy name or like a for the sake of argument kind of a name. A name that doesn't really refer to anyone you know. So that is, we hope to preserve the style of reasoning in this top green box while preventing the kind of reasoning in the bottom box. So here's what the rule looks like, and then we'll see some examples. So it looks exactly like, if you just look at this little description of it, it looks exactly like universal out. It says, look, if you've got an existentially quantified formula, you can take off the existential quantifier and replace the variable that was bound with a constant. That looks exactly like what universal out looks like. If you have your notes, you can sort of go back and look and see that. So v is any variable, c, here's the big difference between universal out and existential out. V is any variable, x, y, or z, but c, when you do existential out, has to be what we call a new constant. It's not any constant whatsoever. You can't pick whatever you want. It has to be new, and I'll say what new means in a second. And then item 3 just talks about how we are supposed to understand fv and fc, as we've talked about before. Okay, so what's it mean for a constant to be new? A new constant is a constant that does not appear anywhere previously in the derivation, not even on a show line. So the idea is that you can do existential out, and you can replace an existentially quantified variable with a constant like a, b, or c, so long as a, b, or c has not appeared earlier in the proof. Of course, once you use it, it's then no longer new, but it was new when you first introduced it, and so that's the requirement of existential out. Hopefully that makes some kind of sense. I think you'll get the hang of it more as we go through some example problems. So that's what the next video will be about, doing some examples of existential out derivations.